So what if the graph we're given is the graph of the first derivative, like the green graph? If we're looking to graph say the second derivative first, based off the first derivative, you have to remember points of inflection based off of first derivative and concavity based off of first derivative. Well, to find points of inflection, we always said there's points of inflection where the first derivative goes from increasing to decreasing or vice versa. So those would be points of inflection would be mins and maxes on the first derivative. So to figure out if the second derivative is positive or negative, you have to remember that a graph is concave down when the first derivative is decreasing and concave up when the first derivative is increasing. So we're concave down from here to here and then from here to here. And concave down means the second derivative is negative. So f prime is negative, f double prime, is negative. And then if the first derivative is increasing, the second, like from here to here, the second derivative is positive. So to graph it, you just use those two facts. There's a point of inflection at -1, and that's also where a second derivative is 0. And there's a point of inflection at 2, also where the second derivative is 0, second derivative. So it goes from negative to positive to negative, negative to positive to negative, and that's how you would graph the second derivative based off that graph being the first derivative. Now, the other thing that you may be asked is graph the original function based off of first derivative. So the thing here is to go backwards like that, we're not going to get an exact graph. I mean, this graph would be the same as this graph as far as that's concerned. Like, it doesn't tell you where the graph is, it just tells you where it maybe changes, increasing and decreasing and such. So you can't get as specific as the last couple questions. And I don't know where I am anymore. Hold on. This is just like regular class. All right, so here we go. So to graph the original function based off the first derivative, just look at where the first derivative goes from positive to negative and vice versa. Because when the first derivative is positive, I'll do the positive parts in red from here to here and here to here. You know that function is increasing. When the first derivative is negative from here to here, from here on, you know that the original graph is decreasing. So we're saying our graph goes from increasing from negative infinity to -2. Then it goes from decreasing from -2 to 0. And then it goes increasing from 0 to 3. And then decreasing everywhere after. So here's -2, here's 0, and here's 3. Those are the key points. Our graph is increasing from negative infinity to -2, then decreasing from -2 to 0, and then increasing from 0 to 3, and then decreasing afterwards. And just as a final check, if the first derivative goes from positive to negative, you should have a max. If it goes from negative to positive, you should have a min. And if it goes from positive to negative, you should have a max. But that looks good. Again, the last thing I want to stress here is that graph that I just drew, we don't know exactly where it is vertically. but we do know that it's shaped like this. So if you drew it like this, that'd be fine. If you drew it like this, that would be fine. So hopefully you understand that. Uh, just let me know if there's any questions.